Okay, so we are going to start. So today we are going to cover a topic called as a functional dependency and normalization. Okay, today we are focusing on this topic. In the last lecture, we focus on the concept of SQL. We discuss basics of SQL, and then we discuss the various questions based on a SQL. Okay, so today we focus on two important topic that will be asked in your GATE exam as well as for your technical exam. First one is a functional dependency, and second one is a normalization. Both these topics are very important as far as your technical is concerned as well as for your GATE exam is concerned. Okay, so I already discussed the GATE syllabus for DBMS. What is a GATE syllabus given for DBMS for GATE? So ER model, relational model, SQL, integrity constraint, normal forms, file organization, indexing, and transaction. So out of this, we already discussed about SQL, and in this lecture, we are going to discuss it about normal forms. So normal form includes two things. One is a functional dependency, and second one is various types of normal form. Then weightage of the DBMS in the GATE exam, that also we have discussed in the previous video, but still again we are discussing it. Okay, in previous lecture we discussed about it. So on an average we can say that 5 to 7 marks question will be there based on the DBMS in a GATE exam. So what is a prerequisite for normalization? Okay, what is a prerequisite? Today we are focusing on normalization. So what are the prerequisites for it? Okay, so you should know what are the prerequisites. So there are two prerequisites are there. One is a concept of functional dependency. In order to solve a numerical or questions based on normalization, you should be clear with the concept of functional dependency and the concept of keys. Okay, these two topics are important for that. So one by one we focus on this. So very first we discuss about the functional dependency. So what is the use of functional dependency, or what do you mean by functional dependency? See, as I clear you that why we are discussing the functional dependency, because functional dependency is one of the tool that can be used in case of a normalization. Okay, normalization will make use of a functional dependency. Okay, so as you are aware about ER diagram, what we are doing in a ER diagram, in case of a ER diagram, we are representing the relationship between entities of the table. Similarly, in case of functional dependency, we are representing the relationship between attributes of the table. Attributes of the table is nothing but the columns which are present in your table. So functional dependency, I can define it's a kind of relationship exists between attributes of a relation. So here we can have x determine y. This arrow symbol is used to represent the concept of functional dependency. Here, how can we read this? X determines y. Okay, so functional dependency will represent a relationship between attributes of the table, whereas ER diagram represent the relationship between entities of the table. So there are various types of functional dependencies are there. Total dependency, or you can say full dependency, partial dependency, transitive dependency, multi-value dependency, trivial dependency, and joint dependency. So these are the various types of dependencies. So we are going to discuss all these dependency one by one. Okay, one by one we are going to discuss this. So very first is a total, or you can say full dependency. So why we are discussing, again I told you that this concept we are going to use in a normalization. So you should be able to identify whether in a given relation there exists total or full dependency or not. Okay, you need to identify. For that purpose, your concept of full dependency should be clear. So what do you mean by full dependency? If a non-key attribute, okay, if a non-key attribute is determined by all primary key attribute, because you know that primary key can be formed with more than one attribute also. There can be a situation where we can form a primary key with more than one attribute also. Okay, so in that case, what is required? It is required that I should use all primary key attribute to identify the non-key attribute. So in this case, what is the meaning of key attribute or prime attribute, or what is the meaning of non-key attribute or non-prime attribute? So the attribute which take part in the formation of primary key, okay, the attribute which take part in the formation of primary key, they are called as a key attribute, and the attribute which do not take part in the formation of primary key, they are called as a non-key attribute. Okay, so here we are discussing the concept of total dependency, or you can say full dependency. So let's discuss this with the help of simple example. So here what I've shown you, this is a simple table I have created. This is what the employee table, which is having 4 attributes: employee ID, project ID, employee name, and number of hours. Now in this case, can you tell me what is a primary key? Kushwant or Ritika, can you tell me what is the primary key for this employee table? Kushwant, can you tell me what is the primary key for employee table?
PID.
PID is a primary key. Suppose I told you PID as a PID as a A11. Again, suppose one more row is there for P. Is it necessary that in one project only one employee should work? No, it is not necessary. In single project, more than one employee also work. So in that case, you cannot take PID as a primary key. Okay. Now, what is another choice, Kushwant or Ritika? PID is not a primary key, because in this case, in one project, more than one employee may work. In this case, I can add one more row. Project ID is 11, but employee ID is 2. Okay, so in that case, PID is not a primary key. Then what is the solution? Kushwant and Ritika, can you tell me what is the option? What is the option? Yes, combination of EID and PID will be treated as a primary key over here. Okay, the combination of EID and PID is a primary key for this table, because suppose you take only EID as a primary key, then you can easily identify the employee name. But can you identify number of hours? Suppose I say employee ID 1, can I uniquely say number of hours as a 5? No. So employee ID alone is not a primary key. Project ID alone is not a primary key. So in this case, primary key is nothing but a combination of employee ID and project ID. Okay, the combination of these two forms a primary key. Now you can check. Suppose I say combination of 111, you can easily say 5. Suppose I say 112, you can easily say 4. Okay, so this is how primary key is formed. So in this case, what are the key attribute and what are the non-key attribute? Employee ID and PID is a key attribute because they take part in the formation of primary key, whereas employee name and number of hours, they are treated as a non-key attribute because they do not take part in the formation of primary key. Okay, so is that clear? What are the key attribute and non-key attribute for this employee table? Okay, now total dependency and partial dependency. We take a simple example, then we understand what is this. Okay, suppose I say EID comma PID determines the value of hours. This is an example of full dependency. Okay, what I told you, combination of EID and PID. Suppose I know the value of employee ID as well as project ID, I can easily find the value of number of hours. So is it an example of total dependency or partial dependency? So it's an example of total dependency. Why it is an example of total dependency? Because the reason is very simple. Because in this case, I am going to use all the key attribute to determine the value of non-key attribute. So it is given if a non-key attribute is determined by all primary key attribute, but not only by part of primary key. Okay, suppose I am using another. Can I say EID determines ename is an example of total dependency? Can I say EID determines the employee name, it is an example of total dependency? Answer is no. What is the reason? Because it's a part of a primary key, it's not a complete primary key. Your complete primary key is formed with 2 attributes, but in this case I'm using only part. And suppose you are using only part of a primary key to determine non-key attribute, then it's not an example of full dependency or total dependency. What is required in the total dependency? You need to use all primary key attribute to determine the value of non-key attribute. So here we can say employee ID and PID determines the value of number of hours is an example of full dependency, whereas employee ID is finding the value of name is an example of partial dependency. So what is partial dependency? If a non-key attribute is determined by only part of a primary key. Okay, in this case I'm using employee ID as a part. Okay, so this is what the difference between total dependency and partial dependency. In total dependency you require all attribute. In partial dependency you are using either of the attribute to determine the value of non-key attribute. Okay, so this is what the concept of full dependency and partial dependency. Now the next type of dependency is a transitive dependency. Okay, so transitive dependency, I think you already aware about this. You already aware about the property of a transitivity property. What is that? Suppose A determines B and B determines C, then we can say that A determines C. So the dependency which follows this transitive property, that dependency we can say that it's a transitive dependency. So again we take a simple example to understand the concept of transitive dependency. Okay, to understand the concept of transitive dependency, we take a simple example. Again we consider here employee table. So in the employee table, what we have? In the employee table, we have these 4 attributes. What are the 4 attributes over here? Employee ID, employee name, department ID and department name. These are the attributes are there. Okay, these are the attributes of the employee table: employee ID, employee name, department ID and department name. So in this case I can say that employee ID determines the value of department ID, whereas department ID determines the value of department name, and employee ID determines the value of department name. So this is what a transitive dependency. EID determines department ID, department ID determines D name, and hence we can say that employee ID determines the value of department name. So this is what an example of transitive property, and the dependency which follows this transitive property is called as a transitive dependency. So in short, how to identify whether in the table there exists transitive dependency or not? If you find one non-key attribute is finding the value of another non-key attribute, what I'm saying, if you find one non-key attribute is finding the value of another non-key attribute, then you can say that there exists transitive dependency in that particular table. Now next is multi-value dependency. So what do you mean by multi-value dependency? Suppose if there exists one-to-many kind of relationship between the attributes of the relation. Okay, if there exists one-to-many kind of relationship in the table, then we can say that it is having multi-value dependency, and multi-value dependency is represented by double arrow. Okay, this double arrow is used to represent the multi-value dependency. So just take a simple example. Here we consider this as a table, course information as a table. So it consists of 3 attributes: course, teacher and textbooks. So what do you think? There exists one-to-many relationship here? If yes, how many one-to-many relationship exist in that table? Can anyone answer? Ritika, Kushwal, can you tell me how many one-to-many relationship exist in this table, course info? How many one-to-many relationship exist over here? 3 one-to-many kind of relationship exist over here. One between course and teacher, second between teacher and textbook, and third between teacher and textbook. Okay, first between course and teacher, second between teacher and textbook, and third between course and textbook. So in this particular table, three one-to-many kind of relationship exist. That's why we can say that it is an example of multi-value dependence. Next, trivial dependency. So what do you mean by trivial dependency? Suppose you got a form like this: alpha determines beta and beta is a subset of alpha. Then we can say that it's an example of trivial dependency. Trivial dependency has to follow this particular property. So let's take a simple example. Combination of roll number and name is used to find the value of name. So here roll number and name is alpha, whereas name is treated as a beta, and this beta is a subset of this. So we can say that here there exists trivial dependency. Okay, trivial dependency exists over here. Then the last type of dependency is there, that is joint dependency. Now what do you mean by joint dependency? Okay, so dependency is said to be a joint dependency if we join all sub table, then we get a original table back. Okay, so what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. So what is the meaning of this? Suppose I have this table A, which I am going to divide into three parts: A1, A2 and A3. Hello, Khushwant, Dikshita, are, am I,
Yes,
yeah,
yes, sir.
Yes,
am I audible?
yes, sir.
Uh,
Yes, sir.
whether my screen is visible to you?
No, sir.
No, sir.
Okay, just wait. I will share again. Okay. See, if any issue if you are not getting sound or whether screen is not visible, you just just unmute yourself and say, "Sir, screen is not visible or audio issue is there." Okay. You have to convey the issue to me. Just wait for 1 minute. I'm going to share the PPT again. Okay. Just wait.
Okay, sir.
Okay. Now it's visible. Kushwan.
Yes, sir. Yes, sir.
Yeah. Okay. We can continue. Okay, so am I audible properly? Pushwant, am I audible to you?
Yes, sir. Yes, sir.
Yeah, okay, thank you. Okay, so here we discuss about joint dependency. Okay, so various types of dependency we are joined over here. Sorry, we discuss over here. Now next is we need to discuss the closure of attributes. How to find closure of attribute. Okay, see, this is again important thing to know how to calculate the closure of a attribute. Okay, so suppose this is a relation R having attributes A, B, C, D, E, F, G. These are the attributes given in the relation, and these are the three dependencies are given to you. A determines B, BC determines DE, AEG determines G. These are the three dependencies are given to you. So you need to find AC closure. Okay, this is called as a closure of attribute. So how to find? So the procedure for finding the closure of attribute is very simple. So here, first of all, I need to take this AC attribute as it is. So here I have taken AC plus, this plus sign represent closure, AC closure. Okay, so here what we have, AC. After that, what you need to consider, you need to consider the left side of this dependency. Okay, so whether A is there, yes, A is there. Okay, so from A what you are getting, B, means in this case, first of all, I need to find AC closure. So what I have done, I have taken AC as it is. After that, I need to check whether any dependency is there which starts from A. Yes, there is a dependency which starts from A. So from A, what I'm getting, B. So I'm going to add B over here. So what I got, A, B, C. Okay. Next is whether BC is present over here. Here BC is present. Yes. So BC give me a D and E. So here I can write A, B, C, D, E. Means DE is added to ABC. That's why we got this A, B, C, D, E. Okay. Then whether A, E, G is present here. A is there, but G is not there. So that's it. So we cannot consider this third dependency over here. Okay. We cannot consider this third dependency because AEG is not present over here. So that's it. So this is what my closure of AC. This is what my AC closure. Did you get the concept? How to calculate the closure of attribute? Okay. Then we take another example over here. Okay. This is another relation given to you, and this is these are four set of dependencies are given to you. A gives BC, CD gives E, B gives D, and E gives A. These are the four dependencies are given to you, and you need to find B closure. Okay, so again you have to find it. So B closure, first of all we need to take this attribute as it is. Now we have to check whether B is present. Here B is there, no. Here whether B is there, no. Here B is there, yes. So we can add B, D. So whether BD or only D is present here, no. So that's it. So this is what a BD is a value for B closure. Okay. So what is the value of a B closure? BD. BD is a value of a B closure that we got over here. Now again we take one more example over here. Again this is another relation A, B, C, D, E, F. Okay, and you are getting this four dependencies over here. AB gives C, BC gives AD, D gives E, CF gives B. Okay, so these are the various dependencies are given here, and I need to find the value for AB. Okay, I need to find AB closure over here. So how can I find AB closure over here? Can you able to find AB closure over here? Anyone? How to find AB closure? Can you able to answer how to find AB closure over here? So first of all, here we need to consider AB. Okay, see, whenever we are finding the closure, first of all you need to consider that particular set of attribute as it is. So here I have taken AB as it is. Then I should check for whether only A or only B is present or only combination is present. Yes, here combination is present, C. So C is going to add it over here. Okay, then after that BC is present over here. So BC gives D. So that D is added over here. Then only D is present. So from D, what we are getting? E. So E is going to add it over here. And in this way, we got A, B, C, D, E. Okay. Can we able to reach F? No, because on the right hand side there is no F. So we can say that this is a B, C, D, E. This is a closure for AB. Okay. AB closure value is A, B, C, D, E. Again, we take one more example to understand this. Now in this case, we don't have to find any closure of an attribute, but we have to check whether this dependency exists or not. What is given over here? BCD gives H. So in this case, we don't have to find closure, but we need to check whether BCD determines H is true or false. Okay, so again our procedure is same. We need to find closure of BCD. So I have taken BCD closure. So as usual, we are taking BCD as it is. Then we have to check whether A is present over here. No. Whether CD is present. Yes. So from CD, what we are getting? E. So E is going to add it over here. So BCD plus E. Then E gives C, but C is already present. So there is no use of this dependency. Then D is there. Whether D alone is present over here? Yes, D is present. So we'll get A, E, H. Okay. So E is already there. So here we are going to add A and H. So we got A, B, C, D, E, H. Okay. So hence B, C, D determines H. Okay. Here H is there. Means BCD is going to determine H. From this we come to know that by using the combination of BCD closure, you can find the value of H. So hence I can say that this statement BCD determines H is true. So this is how you can find closure of attribute. See, in order to solve a numerical based on normalization, it is important to understand the concept of functional dependency, as well as you should aware about the concept of closure of attributes, as well as concept of keys that we are going to discuss. Now till then, you just tell me whether your concept is clear or not. Whether are you clear with the concept of closure of attribute or not? Just give me answer. Are you clear with the concept of closure of attribute? Yes, Dikshita, Kushwant, Pranay, Sanjeevani. Did you understand the concept of closure of attribute? Okay, thank you. Okay, so next we are going to discuss next topic, equivalence of functional dependency. Now in case of equivalence of functional dependency, what is being asked? You have been given some set of dependency, okay, like this. So here I have given one dependency F, this is F dependency, and this is G dependency. Now I have to check whether these two dependencies are equivalent or not. Okay, so which one is true for above dependency? This is a question. Okay, these two dependencies are given to you, and question is being asked to you whether these two dependency these two dependency follow what kind of relationship, whether F is a subset of G, F is equals to G, F not equals to G, or F is a subset of G. Sorry, here G is a subset of F. So which one is true? We need to find. So how to find this? So for that purpose, we follow simple thing. What we need to do? We need to consider left side of a functional dependency F. So here we have considered A, then AC, and then E. As E is repeated twice, I will consider only once. See, carefully understand the procedure, how we are calculating the equivalence of functional dependency. Okay, what I have done over here, I have just considered all the left hand side attributes A, First is A, then second one is AC, and third one is E. So here E is repeated, that's why I taken it for only once. Now I need to take this part. Okay, miss, I'm going to find the closure not by using F, but I'm going to find the closure by using G over here. Okay, I am finding the closure of G over here. Okay, so A closure. First of all I will write A. Okay, so for A gives CD, so CD will be added over here. Now again, is there any possibility whether A, C or D is present here? No. So that's it. So ACD is a closure of A. Then next one is AC closure. So how to calculate AC closure? So whether we need to consider this F? No. We need to consider G. So AC closure. So AC closure, first of all we need to consider AC. But here A is already there, so it returns me C and D. But C already there, so what I'm going to add? D. I'm going to add D over here. Now whether ACD after this, whether E is present here? No. So that's it. So this is what a AC closure. Okay. Now next is E closure. So again procedure is same. First of all we need to consider this E. Okay. First of all we are just consider this E only. Okay, this E only we consider. After that we have to check whether A is there. No, then E is there. E gives what? AH, so AH will be added over here. But yeah, E gives this AH. Okay, now what we obtain? We obtain this EAH. Now again we have to check whether A is present. Yes, here A is present, so this A means for this A we consider this A, so that A gives CD, so C and D will be added over here. Okay, in this way we find the closure of E. Okay, in this way we have we just found the closure of E over here. Okay, we found the closure of E. What we found? We found the closure of E. Now we have to check. Okay, now A gives C. Whether A gives C? Yes. After AC gives D? Yes. Whether AC gives D? Yes, it is giving. E gives AD. Whether E gives AD? Yes, E gives AD. That means the task which is done by F is also done by G. What is the meaning of this? We can say that F is a subset of G. Why we are saying this? Whatever the task that is done by F is to be carried out by G. That's why we can say that F is a subset of G. Okay, here we can say that F is a what? Subset of G. This is the first. Okay, we need to consider second thing. Okay, now after that what we need to do? We have to consider only left hand side attributes of dependency G. So A and E. Again, in order to calculate closure of A and closure of E, whether we consider G? No, we have to consider F. So find the closure of A. So first of all you need to take A as it is. Okay, here you need to take as it is A. We have taken it. Then we have to check for A. What is there given? Yes, A gives C. So what we have added? We have added C. Now again AC is present over here and here also. So AC gives D. So we are going to add D also. Okay, so here we have added D also. Now again, is there any possibility? But here E is there, but E is not there. So that's it. So this is what A closure. We got A, C, D. After that we need to find E closure. Okay, after that we need to find E closure. So again procedure is same. First of all we need to consider only E. Then we have to check whether E is there. Yes, E gives AD. So E gives AD over here, and E gives H also. So we consider EDAH. Okay. After that A is giving C. So A is also present. So A gives C. After that AC gives D, but D is already there, and that's it. So here we obtain all the attribute A, C, D, H, E. Okay, that's it. So in this way we found A closure and E closure. Now what is next? We have to check. Okay, we have to check A gives CD, whether A gives CD is present here or not. Here A gives CD, so here also you got A gives CD. Yes, it is true. Then second, E gives AH, whether E gives AH is present. Yes, E gives AH is present. That means you can say that G is a subset of F. So here we found that F is a subset of G and G is also subset of F. So what is the meaning of this? Its meaning is very simple. That means what we can say, F is equals to G. So this is the answer of this particular question. In this case, we need to check whether these two dependency are equivalent or not. Suppose they are equivalent, what kind of relationship exists, whether this one, this one, this one, or this one. So as we got, F is a subset of G and G is a subset of S, G is a subset of F, then we can say that F equals to G. So this is how we found equivalence of functional dependency. I know that this topic is somehow complex, but you need to understand this. Again, one more time, I am going to repeat. Do you want me to repeat, or I need to consider another example? Yes, tell me whether I need to repeat this, or you got the thing. What do you want? Do you want to repeat me the same question, or I need to consider next question? Yes, Dikshita, Kushwant, Pranay, Sanjeevni, can you answer? Got it? Okay, next question. Not an issue. We'll go to next question. Okay. Now, in this case, this is again question of finding the equivalence of functional dependency. Okay. Now again, these two dependencies are given to me. There is one relation R having attribute PQRS, and two dependencies are there. One is X dependency and Y dependency. And again here we need to check what kind of relationship exists between X and Y. Whether X is a subset of Y, whether Y is a subset of X, or whether X equals to Y, or whether X not equals to Y. Now I want answer from your side. Okay. Now I want answer from your side. I just wait for 2 minutes and you just give me an answer. Which option is true? First one, second one, third one, or fourth one? This is how you have to solve. I already explained the procedure, how to solve. Okay? I already explained the procedure, how to find the equivalence of X and Y. So just take for 2 minutes and try to give me answer whether these two X and Y are equivalent or not, or what kind of relationship exists between this. See, you try to solve by yourself, then and then your concept will be clear. So try to solve it. Suppose you understand the procedure, try to solve this question and tell me out of this 4 option, which option is true. I will give 2 minutes to. Okay, did you get your answer? I'm just displaying the answer. Now by just looking at this, can you able to answer which option is true? First, second, third, or fourth? Now I just shown you the answer. From this, you have to just tell me which one is true. Which option is true for this particular dependency? First, second, third, or fourth? Which option is true? Okay, suppose you didn't get answer of this. Now pay attention towards it. First of all, what we need to do, our procedure is we need to consider left hand side attribute of this dependency X. So we have to find P closer, Q closer, and R closer. But in order to find P, Q, R closer, do we need to consider this dependency X? No, we need to consider the dependency Y. So P closer, first of all, we will take P as it is. Okay, first of all, we'll take this P as it is. Then from P, what we get? P gives QR. So we reach up to PQR. Then R is there. Whether R is present over here? Yes. So R gives S. So in this way, we found closure of P as a PQRS. Next, we need to consider closure of Q. So we need to take Q as it is, but here Q is not there. Here Q is not there. Here Q is not there. So this is only Q. Then we need to consider R. R closer. So we have to take R as it is. Whether R is present? Yes. Here R is present. So R gives S. So we are going to add S over here. So in this way, we got the R. Okay. Now next, what is next? We need to consider, we have to check this, whether P gives Q. Yes, P gives Q. So it is satisfied. Then Q gives R. Whether it's satisfied? No, it's not satisfied. The second condition is not satisfied. Third, R gives S. Yes. So this condition is satisfied. So can I say X is a subset of Y? No, because this condition is not satisfied. That's why I can't say X is a subset of Y. Now next step, we need to consider left hand side of a Y. What is that? P closer, R closer. And in order to find P and R closer, we need to consider which dependency? Whether we consider Y? No, we consider X. So again we take closure of P. Will remain as it is. Now here what P gives? P gives Q. So I will write Q over here. Now I got P and Q. So Q is also present over here. Q gives R. So R is added over here. Whether R is present? Yes. So R gives S. So in this way we got PQRS. This is a value of P closer. Now next I need to find the value of R closer. Okay. R closer is there. So value of R will take as it is. Then whether P is there? Yes, R is present directly over here. So R gives S. So here I will write RS. So this is what a R closer. Now what is next step? I need to check whether this condition is satisfied or not. P gives QR is present here. Yes, P gives QR. That means this condition is true. R gives S, whether it's satisfied? Yes, R gives S. So it is satisfied. That means I can say that Y is a subset of X. Y is a subset of X. That's why this is what my answer. This is what my answer. This is not possible. We have just seen. So is it possible to have X equal to Y? No, because they are not equal. And this is also. So your answer is this one. So this is how you can find equivalence of functional dependency. Now, are you clear with the concept of equivalence of functional dependency? Just reply whether you understand how to find equivalence of functional dependency. Pushpant, yes. What about others? Pranay also got the thing how to find the value of X and Y, or how to find how to check whether given dependency is equivalent or not. We have checked this. Okay. Is there any doubt? All of you clear? Can we move to next question or next technique, which help us to find how to find the closure? We have just checked how to find the closure. Now we check next thing over here. Okay, we consider the next topic. Okay, so our next topic is equivalence of functional dependency. So that is just we have checked. Okay, just we have seen how to find the equivalence of functional dependency. Okay, so do you want me to take this question, or I can continue with the next question? Do you want me to take this question again? Or we can take next topic. Okay, can we take next topic, or we'll take this same question again, means similar type of question? This we have consider, this we have consider. This is the next question. Again we got this two dependency, f and g, and we need to check whether they are equivalent or not. Do you want me to solve this question, or we need to consider next topic? Can you reply, Kushwant? What do you want? Do you want to do you want me to discuss
Next
this?
topic.
Next topic? Okay, yeah,
Yes, sir.
we cover next topic. Next topic is types of keys. Okay, the next topic is what are the different types of keys are there. Okay, what are the different types of keys are there? So there are various types of key: candidate key, super key, composite key, primary key, foreign key, and alternate key. So out of these keys we are interested in three main keys. What are that? Candidate key, super key, and primary key. But most important key while solving normalization numerical are candidate key. Candidate key is a very important type of key that you need to consider while solving a numerical based on normalization. Okay, so let's discuss this. So this is what my simple table. So what are the examples of super key over here? So what is super key? Simple definition is there for super key. Super key is a set of one or more attribute that can identify all record. Why we are using the concept of key in your database? Because we need to identify every row of the table uniquely. In order to find every row of the table uniquely, we are going to make use of a super key. Okay, so here only roll number is an example of super key. Only enrollment number is also example of super key. Email id, only email id is also example of super key. Then combination of roll number and enrollment number, combination of roll number and name, combination of enrollment number and branch, this is also a example of super key, because super key is the set of one or more attribute. Okay, it's a set of one or more attribute. This relationship is very important. Super key is a superset, then candidate key is there, and then primary key is there. So suppose in my attribute, suppose in my table, how many attributes are there? 5 attributes. So I can form a super key with all these 5 attribute also. So this is what the super key. Next one is candidate key. What is candidate key? Candidate key is nothing but a minimal super key, and in this case we should know how candidate key is different from super key. Okay, so in this diagram what it shows, candidate key is a subset of super key. Candidate key is a subset of super key. So I can say all candidate key are super key, but all super key are not a candidate key. So this is very important thing to understand. Candidate key means you have n number of super key. Out of this you need to decide what is my candidate key. So here all these 4 are examples of super key. So out of this what do you think? Which is an example of candidate key? Can we say roll number is a candidate key? Yes. So in order to check a particular key is a candidate key or not, because you need to consider all super key to select a candidate key. So you need to remember two conditions. What are they? First condition is it's a minimal super key, and second condition is important. Particular super key is called as a candidate key only when the subset of the same key is not a super key. See, again I'm repeating. What is second condition? A particular super key can be called as a candidate key only when subset of this super key is not a super key. Okay, don't get confused. I will give simple example. Now in this case, can I say the combination of name and address? Combination of name and address is a with the combination of name and address is an example of super key, candidate key, or both. Whether it's an example of super key, yes, all these are the examples of super key. But we need to consider what? We need to consider the example of candidate key. Can we say roll number is a candidate key? Yes. Answer is yes. Roll number is a candidate key. Enrollment number is also candidate key. Email ID is also a candidate key. But the combination of name and address, is whether it's a candidate key, whether it's an example of candidate key. Yes, it is also example of candidate key. Okay, it is also example of candidate key. Why? Because subset of this, whether subset of name, whether alone name is available, whether alone address is available, no. That means we can take this combination as a super key as well as example of candidate key. So this is how candidate key different from super key. Okay, don't worry, we'll take more example to clarify your doubt. Next one is primary key. Now one of the candidate key selected as a primary key. So okay, in the previous example we have seen these all are candidate key. So in this case I need to select one as a primary key. Now primary key is to be decided by the database administrator. Means out of this four candidate key, your database administrator will select one candidate key. So which it be selected. So while selecting a primary key, your concept is very clear, that your primary key should be very efficient. Can we take a combination of name and address as a primary key? Obviously my answer is no, because in this case two attributes are there. Instead of this, I will choose such an attribute which is very frequently going to be changed. So I can say enrollment number is my primary key. See, it is not a case. It is going to differ from database administrator to database administrator. Some database administrator will select enrollment number as a primary key. Some database administrator will select roll number as a primary key. One of the candidate key can be treated as a primary key, and this is what a relationship between super key, candidate key, and primary key. Okay. So in this case, as my database administrator have selected enrollment number as a primary key. And one more thing I can consider over is scope. Why I'm not going to select roll number? Because the scope of roll number is only restricted to college, but the scope of enrollment number is covered at a university level. Suppose one more ID is there, Aadhaar number. So suppose roll number, enrollment number, and Aadhaar number, these are three candidate key are there, and I need to select one as a primary key. So which I will select? Obviously I will select Aadhaar number, because Aadhaar number scope is more as compared to roll number as well as the enrollment number. So one more thing is there, while selecting a primary key, you need to consider the scope of an attribute. Okay, so these three types of keys are important to us in normalization. foreign key is there. So foreign key is not that much important in normalization. So we know that in case of foreign key concept, there is one parent table and there is one child table. Parent child kind of relationship exists. In order to establish a relationship between two table, we require the concept of foreign key, but we didn't require foreign key concept in normalization. Okay, next concept, example of key. Now this is important, carefully understand this. Suppose we have given this dependency. This type of question will ask in your technical exam as well as in your gate. Okay, so you are given relation R gives A B C D and only one dependency is given to you, A gives B C. Now you have to find what is a candidate key. Okay, what is the candidate key for this relation R? Okay, so I can say A closer. Can I say A is a candidate key for this relation? So for that purpose, first of all, I will consider A gives A remains as it is. You already aware about how to find the closure of attribute. So we need to consider this attribute as it is. So we have considered A as it is. Now here, whether A is present, yes, A gives B C. So we got A, B, C. So can we say A is a candidate key? Yes. So in this case, one more important thing I will tell you about candidate key. We want such a combination of attribute from which all attributes of relation should be reachable. Then and then that combination of attribute can be treated as a candidate key. In this case, I'm saying that this A is a candidate key. Why? Because by using A, I can able to reach A, B, C. Sorry, in this case, this is not an example of candidate key. Reason is very simple, because here by using A, I cannot reach up to D. Sorry, I just I told you in different way. Don't get confused. Again, I'm telling you. Okay. See, candidate key is very important, and how you need to find candidate key. First of all, you need to find the closer. Okay, so I'm finding the A closer. So what I got? A, B, C. So here whether D is present, here D is not present. That's why A is not a candidate key. For this relation, candidate key is not there. Now can you ask me, sir, why you have taken only A? Why B and C is not there? Suppose I take B. Can I able to find B closer? Any dependency is there? No. Can I find C closer? Any value is there? No. So there is no candidate key for this given relation. Now second example. This is what my second example. Now here I need to find the keys. What are the different keys are there? Okay. So here first of all I will check ABC, whether ABC is a candidate key of this relation or not. So for that purpose our procedure is very simple. We need to take the closure of all this. So we'll take a closure of ABC. How to find closure? We need to consider ABC as it is. Then we need to consider this. ABC is present over here. ABC gives D. So D is added over here. Okay. So in my relation, how many attributes are there? 4. A, B, C, D. So I reach A, B, C, D. That means it is a super key. Okay. This is what my super key. See, we'll see here what is a super key for this table, what is a candidate key for the table, and what is a primary key for this table. Currently, we are considering only super key. So here I can say no super key is there in this particular table. So in this case, there is one super key, ABC. Then I will tell you candidate key. Don't get confused. Okay, first of all, we focus on super key, because super key is a superset, then candidate key, and then primary key. Now second, AB. Now check, find out the AB closure. So AB closure, how to find out AB closure? AB gives, first of all, AB. Okay, I consider only this AB first. So AB is present over here. So CD is going to add it. So CD. So I got all these 4 attributes, A, B, C, D. So this is also example of super key. Now finally A closure I need to consider. From A what I'm getting? B, C, D. So I consider B, C, D, and I will take as it is. So from this also I'm getting all the values. Hence I can say that ABC, AB and A, all these are super key for relation R. All these three are super key for relation. Now I want to select candidate key. Okay, I told you about super key and the candidate key. So what difference I told you? I told you that minimal super key is nothing but the candidate key. So out of these three key, which is a these three are super key, but we need to decide which is a candidate key. Can I say ABC is a candidate key? Now I want answer from your side. Yes, Kushwan, Dikshita, Sanjeevni, Pranay. Can you tell me uh, whether ABC is a candidate key? Can you give answer?
No,
No.
sir.
Dikshita says no. Okay, why ABC is not a candidate key? Because it's not a minimal subset. Which is a minimal subset? A. A is very efficient. Okay, see, these three choices are available with me: ABC, AB, and A. So I'm asking you whether ABC is an example of candidate key or not. So answer is no. So answer is miss. The answer is very simple. Why is it so? Because it's not a minimal set of super key. Minimal means we want minimum combination of attribute. This is one. Second criteria is that what is the second criteria? Any super key. Okay. See, second criteria is this: a super key is called as a candidate key only when its subset is not a super key. Now we have to check ABC whether any subset of ABC is present. Yes, AB is a subset of ABC. A is a subset of ABC. So AB is a super key. AB is a super key and A is a super key. That's why ABC is not a super key. This is another reason. See, always there is a confusion while selecting candidate key from n number of super key. First of all, you need to consider a minimal super key, and second, this condition. A super key, particular super key is a candidate key only when its subset is not a super key. In this case, AB is a subset of ABC and AB is a super key. That's why ABC is not a super key. Now second, whether AB is a candidate key? No, because A is a subset of AB and A is treated as a super key. That's why AB is not an example of candidate key. Can I say A is an example of candidate key? Is there any possibility that any subset of A is there? No. So this is final. Hence, I can say that A is an example of super key as well as candidate key. Are you clear? Are you clear? See, getting the differentiation between super key and candidate key is very important. Suppose you understand this, you can easily solve the numerical based on normalization. There is no problem while solving this. Are you clear? Just reply. Are you clear or not? Yes, Pranay saying yes. What about others? Just quickly reply. Reply guys fast so that I can move to next topic. Okay, and so next, can we take next example? Yes, we consider next example. What is next example? Argues AB CD, argues AB CD, and B gives. See, this is a relation given to you. Okay, this is the relation given to you. Argues ABCD, and these are two dependencies are given to you. B gives ACD and ACD gives B. So again, we need to find super key. Sorry, first of all, we find super key, then we'll find the candidate key. Okay. Now, first of all, we need to consider B. B closure. What is the value of B closure? Okay. So first of all, we'll take B as it is. So from B, what you are getting? ACD. So ACDB. Okay. So this is one of the super key. First we focus on super key and then we'll focus on candidate key. So this is what a example of super key over here. Then second one is ACD. We can take ACD. First of all, we take ACD as it is. So whether ACD is present, yes, ACD. So ACD gives B, so B is also there. Now in this case, the B closer and ACD closer both are my super key. Now tell me which is a candidate key, whether only B closer is a candidate key or combination of ACD is a candidate key. If you able to answer this question, then I can say that you understand the concept. What is my question? My question is very simple. Whether, see, I can say that B, only B is a super key, only ACD is a super key. But my question is, which is a candidate key out of these two? And why? Yes, give me answer. Pushwant, Pranay, Dikshita, Sanjeevni, give me answer. B is a candidate key. Okay, I got one answer that B is a candidate key. Pranay saying it is minimal. Yes, in this case, yes, in this case, you can say that B is a candidate key. B is an example of candidate key because I told you two condition. One is a minimal set should be there, and second, what is second condition? What is second condition? Try to recall. A super key is called candidate key only when its subset is not a super key. Now in this case, okay, ACD. Whether any subset of ACD is there, whether only A, just if you consider only A, whether A is a super key for this relation R, from A, are we getting anything? No, A is not a super key. See, I'm telling you, what are the options are available with us? Okay, first option is A. Because what are the subset of ACD? First option is A, second option is AC, third option is only C, fourth option is C, D, and fifth option is only D. Suppose all these five are not a super key, then I can say ACD is a candidate key for this relation. Now we have to check. Suppose I need to find A closer. Is there anything available? Only A is there? No. So here we got nothing. Then for AC, whether AC is present, but here D is also present. That's why you got nothing over here. See, additional attribute is not there. Okay, means it is not considerable. Here in this case, D is there, but here only AC is there. Suppose here I have AC and here any dependency starts with A, so then it will consider, but here AC is there, but here D is additional, so we cannot consider ACD. So here we got nothing. Similarly for C, only C is available? No, that's why here we got nothing. That means it is not a super key. Then for CD, whether only CD is present? No, additional A is present. So CD got nothing. Similarly for capital D, whether only capital D is there? No. So here we got nothing. That means there is no subset of ACD is a super key. Hence, ACD is also candidate key and B is also candidate key. Though our first condition is minimal set. Okay. But you need to consider both these two conditions. You have to check this second condition also. This second condition is also important. Most of the time you may get confused. You are saying that in this case only B is a minimal subset, that's why it is a candidate key, but this is not a true. Just because of this condition. That's why for this relation, B is also a candidate key and ACD is also a candidate key. Now just reply, are you clear? Kushwan, Pranay, Dikshita, Sanjana, are you clear? Why ACD is a candidate key for this relation. Okay, you got the answer. Yes. So you just need to remember this. Now, last example. This one. You have been given a this relation R, A, B, C, D, and this dependencies are there. A, B gives C, C gives B, D gives A. Now here we have to check what is the candidate key for this. So before candidate key, first of all we need to find super key. After super key, we'll go for candidate key. Okay. Now here AB, whether AB, so we need to find closure of AB. So this AB remains as it is. So from AB we got C, then from C we got BD, but B is already there, so we have added D. So we got A, B, C, D. In my relation only 4 attributes are there, hence I can say AB is a super key. Now next, C closure. I need to find C closure over here. So from C, what you got? BD. First of all, we write C as it is. Then from C, you are getting BD. So we got CBD. Then from D, you are getting A. So A is also added over here. So we got A, B, C, D. So all 4 attributes are covered. That means this is also a super key. Then third one, D. D gives D over here. First of all, D gives D. Then D gives A. So here you consider A. Now, whether anything possible over here? No. So this is not a super key. Suppose D is not a super key. Is it possible that it's an example of candidate key? No, because we know that candidate key is a subset of super key. Suppose D is not a super key, then there is no possibility that it's a candidate key. Now I want answer from your side. Which one is a candidate key? Whether AB is a candidate key or whether C is a candidate key? Just reply. Or both are candidate key. Kushwan saying both. Pranay, Dikshita, Sanjana, reply both. Dikshita also saying yes, both are candidate key. Miss, here I have written, that's why you're saying, or you apply logic? No, I think you applied logic. That is there any subset of C? No. That's why C is a candidate key. And whether any subset of A or B, subset of AB is there? No. Subset of AB is either A or either B. So whether I can say A is a super key or B is a super key. From A, can I able to get all these 4 attributes? No. From B, can I get all 4 attributes? No. That's why C is also a example of super key and AB is also example of super key. Sorry, candidate key. AB and C both are the example of candidate key. Now I think you got the thing how to find candidate key. Now next topic. Okay, we move forward to next topic. Finding the number of candidate key. Now I want answer from your side. Find the candidate key for this relation. Now you just apply your logic and tell me what are the candidate key for this relation R gives ABC. Tell me how many candidate keys are there and what is your answer. Can you say only A, can you say only B, can you say only C or AB or BC? Just tell me what is the candidate key for this relation. I want answer from your side. I will just wait for 2 minutes and you just give me answer. Try to calculate answer by yourself. And tell me what is the candidate key for this relation. And you have to consider this condition. Super key is called as a candidate key only when its subset is not a super key. And candidate key is a minimal super key. Candidate key is very important part in normalization. Suppose your concept of candidate key is clear, then you can solve n number of questions. That's why I'm taking practice of this. And I'm asking you to solve this question. Just tell me the answer. What is a candidate key for this relation? Okay, Kushwan saying 0. Okay, anyone? Whether answer is correct? Yes. Whether answer is correct? Kushwant is saying 0. No, answer is not correct. Let me tell you, this is another twist in candidate key. Okay. See, one more trick I'm going to tell you. In this case, first of all, you need to consider right hand side. Okay. 0 is not a right answer, Kushwan. Okay. I'm going to explain why this is not true. First of all, you need to consider right hand side and you need to find such an attribute which is not reachable. So in this case, A is reachable, B is reachable, C is reachable. Which attribute is not reachable? D. That's why here we need to consider here essential attribute is D. Okay. Here essential attribute is D. Why? Because for D no incoming edge is there, means no dependency is given through which we can find the value of D. That's why D is very important. Here essential attribute is D. So here one thing is very clear, whatever will be the combination of attribute I need to select, in that attribute there should be D. Then and then I can find the candidate key. Then and then I can find the candidate key. Now here directly we are jumping to candidate key. Okay. Now here, so what is there? I will add this D with A. I will add this D with B. I will add D with C. So here I got AD, BD, C. Now I have to check its closure. Suppose its closure giving me all the attributes, then I can say it's a example of super key, and then it's an example of candidate key. Okay, for that we have already rules. So first of all we find closure of AD. So closure of AD, so AD will remain as it is. So from A you are getting B, and from B you are getting C. That's so here you got A, B, C, D. That means we can say AD is a super key. First of all we consider it as a super key. After that BD. So BD will take as it is. So from B what you are getting? C, and from C you are getting A. So you got A, B, C, D. That means BD is also example of super key over here. Okay. Now again you take an example of CD. Again you will take an example of CD over here. So CD will take means you will take CD as it is, CD. So from C you got A, and from A you got B. So CD is also example of super key. Now we have to consider which is a candidate key. Which is a candidate key out of these three, because these three super key we have found. Now which is a candidate key? Again our rule, these two rules are there. Is there any subset of AD is possible, whether any subset of BD is possible, whether any subset of CD is possible? No, because without D no key can be complete. Okay, that's why all these three are candidate key for this relation. Okay, all these three are the key. All these three are the key for this particular relation, which can be called as a candidate key. Clear? Then you can take another example. Try to solve it this. So in this case what I'm doing, again I'm taking the relation R A B C D, and here there are two dependencies are given. AB gives C, AB gives CD, and D gives A. So here you have to find the candidate key. What is the candidate key for this relation? So in this case again we need to check on right hand side which is an attribute which is not reachable. Here you can see CD is there, A is there, but whether B is present on right hand side? No. That means B is a essential candidate. Means while finding the candidate key, first of all you need to find what attribute which is not reachable. So you need to consider it as a essential, because without that attribute your key cannot be formed. Just like that here Kushwant is saying it has 0 candidate key because C is not reachable. Okay, because super key or candidate key is when we say that particular attribute or a set of attribute considered as a super key or candidate key, when it can generate all the values. Okay, when it can generate all the values, then and then we can say that it's an example of super key or candidate key. So here essential is what? B. B is an essential attribute over here. Now AB gives, so again we have to add this B. So in AB already B is there, so in D we are going to add B. Okay, and one more combination we can take, CB. So we have to check AB. AB closer, we have to find AB closer. So AB gives CD, so ABCD we got this. Then for BC or CB, BC is given. Is there any possibility? No. So only BC, so it's not a super key or a candidate key. Then third one is DB or BD. So DB I will write as it is, but from D I'm getting A. So I got A, B, C. So from AB I got CD. So here I got A, B, C, D. Okay, so I have two answer as a super key, AB and DB. Now I have to decide whether they are candidate key or not. Okay, is it possible to have any subset of AB or DB? No. So there is no possibility that any subset can be there. So hence AB is also candidate key and DB is also a candidate key. So in this way you have to find the answer for candidate key. Similarly, one more question is there. Okay, this is another question, and this is another question that you can solve. Okay, so a number of examples we are considering over here. Okay, so this is another example where you need to find a candidate key. This is another example where you need to find a candidate key. So just tell me whether you understand how to find candidate key, so that we can move to next topic, because we are running out of time and we need to consider, or we need to cover more topic. Okay, whether are you clear how to find candidate key? Just reply so that I can move to next topic and I cover gate question also. Okay, Dikshita is saying yes, Kushwant is saying yes. Okay, we'll move to next topic. This is another way of finding, this is another example where we are finding the candidate key, but just because of time I'm not going to cover this. Okay, so we need to cover the example based on this. Okay, so now next we discuss about the normalization. First of all, you should know why there is a need of normalization. Okay, why there is a need of normalization. So what problem you observe over here? What problem you observe over here? So in this table, suppose I need to add new course information, just like VB. So in that case, what is the problem? No student is there. Whenever first time any course is introduced, at that time no student is present over there. So their value is kept as a blank. Here you can see the value is kept as a blank over here. Okay. So in this case, insertion problem is there. Suppose I need to add information of only course, then there is a problem. Other values are kept as a null, and null value always creates problem in the database. So that is called as a insertion anomaly. Suppose I want to delete only information of a student whose roll number is 102. Okay, so suppose I delete the row number 2. What will happen? I am also going to delete the information of course also, that is Oracle. So this is called as a deletion anomaly. In case of a deletion anomaly, you try to delete one kind of information, and just because of this, other kind of information also get lost. So this is called as a deletion anomaly. And third one is a updation. Suppose I want to update the phone number for roll number 102. So how many rows are there? 2 rows. This one and this one. So how many time I need to update this? I need to update 2 rows. But suppose by mistakenly I have updated the roll number for, I have updated phone number for roll number 102 in only second row. Okay. So in that case, this old number remains as it is. Suppose new phone number for 102 is 456. So I'm going to update in second row also and third row also. Suppose in this case, suppose 10 rows are there, then what will happen? I need to update in the 10 rows. Okay, so this is considered as a updation anomaly or updation problem. And finally, updation anomaly also create inconsistency. How? Suppose I am updating the roll number, I am updating phone number only in the second row, and I'm not updating in the fourth row. So in that case, what will happen? In the one row, phone number is 456, and in one row, phone number is 234. So it causes inconsistency. So this particular table face insertion anomaly, deletion anomaly, updation anomaly, and inconsistency problem. The reason is very simple. In this case, we have embedded two types of information. One is a course information, and second one is a what type of information? Student information. Here I have embedded two types of information. That's why here I face a problem. So what is ultimate solution? So solution is very simple. What I need to do? I need to split this table into number of subtable, and then we'll see whether these three problems are overcome or not. We have to check whether these problems are overcome. Suppose I split this one last table into number of three subtable. Okay. So what is your situation? I have divided this one table into what? Three subtable. This table 1, table 2, table 3. Now in this case, suppose I need to insert course info, new course such as VB. So I can easily add over here. I can easily add, and you don't have to add a student information. Okay. So that insertion problem is solved. Suppose I want to delete only student information. I can delete it from here. So in that case, subject information will remain as it is. That means deletion problem is also overcome. Now I want to update the phone number of the student. So 102. So I will update only once. That means updation anomaly is also solved. So this is how we require normalization. This is what a table where we store two types of information. One is a student information, and second one is a course information. When we add two information in one table, in that case we face a problem. But what we have done, we have just split this one last table into number of subtable, then that problem get solved. That's why we require normalization. So what is normalization? It's a process of decomposition so as to reduce what? It's a process of decomposition so as to reduce the redundancy from a relation. The main objective of a normalization is to reduce the redundancy. Always redundancy creates a problem. Okay, so normalization is the process of decomposition so as to reduce the redundancy from a relation. Okay, so this is what a normalization. There are various types of normal forms are there. So this is what example of first normal form. So condition is very simple. For first normal form, value should be atomic. That means the domain of each attribute should be a single value. Multi-value attributes are not allowed. Or in short, I will tell you how to identify whether given table is in a first normal form or not. You need to take what? Intersection of row and column. Okay, suppose this is row and this is column. With intersection of S1 and product ID. How many values are there? 4. P1, P2, P3, P4. So this is what 4 different values are there for S1. So this is not atomic. Okay, and in first normal form we want that only one values to be associated with each attribute, but here 4 values are associated with product ID. That's why this particular table is not in a first normal form. So to bring this table in a first normal form, what we'll do? We'll do the next. Now can I say this table is in a first normal form? Anyone reply? Can I say that this table is in a first normal form? Answer is yes. Why? Because suppose you take intersection of row and column, you always find only one value. That's why this table is in a first normal form. But what is the problem in that particular table? Okay, whether this table is present in a first normal form or what problem you occur. Suppose I need to insert only product information. Suppose the product P3 is there and whose quantity is 500. So here I am going to add P3 with 500, but I didn't have supplier information. That means in this table we are facing insertion problem. I have only product information, but I didn't have any supplier information. So I face a problem over here. Okay, I'm facing a problem over here that supplier information is not there. Then suppose I need to delete only supplier information. I need to delete only supplier information for S4, but ultimately I'm also going to delete the information of product. That means I'm facing what problem? Deletion problem. So in that case also I am facing problem. So now we have to check whether this table is in a second normal form or not. So for second normal form, two conditions you need to follow. It should be in a first normal form. Okay, what are the conditions for second normal form? That your table should be present in a first normal form. Okay, your table should be present in a first normal form, and partial dependency should not be there. Partial dependency should not be there in a second normal form. So in this table is not in a second normal form. Why is it so? Can you tell me what is the primary key for this particular table? Yes, I want answer from your side. What is the primary key for this table? Whether supplier number is a primary key, or whether product number is a primary key, whether status is a primary key, CT is a primary key, or quantity. I want answer from your side. What is the primary key for this particular table? Yes, you can give answer. Kushwant. Product number. Suppose I say product number P1, or suppose say product number P2. Can I get unique value? 200? No. For P2 200 is there, for P2 400 is there, for P2 200 is there. That means combination of supplier number and product number is a primary key. Okay, but suppose I know supplier number, can I tell it CT? Yes. Suppose I say S1, you can easily tell the CT. So in this case, what are the key attribute? Supplier number and product number is a key attribute. Status, CT and quantity are non-key attribute. So in that case, there exists partial dependency. Which partial dependency? If I know the value of supplier number, I can easily find the value of CT. So as in this table, there exists partial dependency. This table is not in a second normal form. So to bring this table in a second normal form, what we'll do, we'll divide this table into these two subtables, supply details table and product details table. Now check whether these two tables are present in a second normal form or not. You just check whether these two tables are present in a second normal form. Give me answer. Yes or no? Whether this table is in a second normal form? Yes. Kushwan saying yes. Yes, the answer is yes. Why is it so? Because in the supply details table, what is the primary key? Primary key is only supplier number. And suppose my primary key is formed with only one attribute, is there any possibility of partial dependency? No. That's why supply details table is in a second normal form. Then you have to check for product details table. In product details table, what is the primary key? Only supplier number or only product number is a primary key? Answer is no. You have to take the combination of supplier number and product number. So in that product table, there is a possibility of a partial dependency. But by using only supplier number, can I find quantity? Answer is no. Suppose by using only product number, can I able to find quantity? No. That's why product table is also in a second normal form. Okay. Now next is third normal form. Again, for third normal form, two conditions need to be satisfied. First condition is that it should be in a second normal form, plus transitive dependency should not be there. In second normal form, partial dependency should not be there. In third normal form, transitive dependency should not be there. Okay, so we have to check whether transitive dependency is present in the supply details table or not. Transitive dependency means what? A determines B and B determines C. Hence, I can say A determines C. Or in another way, I have just given you small tip how to find whether transitive dependency is present in the given table or not. What tip I have given to you? Suppose you find one non-key attribute is finding the value of another non-key attribute. That means that table is not in a what? That means that table is having transitive dependence, and you have to just check in supply details table what is the primary key. Only supplier number is a primary key. So supplier number is a key attribute. Status and CT, these are non-key attribute. This is key attribute and these two are non-key attribute. And suppose I know status of city, then can I tell you the value of city? Answer is yes. Status is nothing but a pin code. Suppose I know the pin code of a particular city, I can easily tell the name of that city. That means here one non-key attribute status is finding the value of another non-key attribute city. That's why in supply details table there exists transitive dependency. Supplier number find the value of status, status will find the value of city, hence you can say that supplier number can find the value of city. And in the third normal form, transitive dependency is not allowed, hence supply details table is not in the third normal form. So to bring this table in a third normal form, what we'll do, we just divide this table, supply details table, into these two tables, supplier city relation and city status relation. So in that case, one is a primary key and here this is one primary key, so only one non-key attribute is there, so there is no possibility of, so in this case there is no possibility of transitive dependency, and that's why these two tables are also in what, third normal form. Okay, these two tables are also in a third normal form. What about this product table? In product table, what is a primary key? Primary key is formed with these two attributes, so only one non-key attribute is there. That means there is no possibility of transitive dependency. When there exists the possibility of transitive dependency, suppose more than one non-key attribute is present in that table, but in product details table only one non-key attribute is there. That's why product details table is not having transitive dependency. That means this table is in a third normal form. So this is what a condition for third normal form. Now next is a BCNF. So again for BCNF, two conditions are necessary. First, it should be in a third normal form, and second, no non-key attribute should find the value of key attribute. What is the meaning of this? I will explain, don't worry. I'm just explain this with the help of simple example. Okay, so here you can see this particular diagram. From this diagram, what you understand, I have written over there that this first is in third normal form, first table, this relationship. See here I am saying it is in a third normal form but not in a BCNF. Why is it so? How I come to know that this is in a third normal form? Because AB is a primary key, and by using AB of finding the value of C, and by using AB of finding the value of D, so no C value is finding the value of D, hence no transitive dependency. That means it is in a third normal form. But this is not in a BCNF. Why? Because in case of BCNF, no non-key attribute should find the value of key attribute, but here you can see non-key attribute C is finding the value of key attribute, because A and B together form primary key. So that's why A and B treated as a key attribute, whereas C and D are the non-key attribute. Okay, so here one non-key attribute C is finding the value of key attribute B. That's why this table is in third normal form but not in BCNF. So what we have done, we have just divided this into two subtables. So here you can't see that non-key attribute finding the value of key attribute. That's why this table also in third normal form and BCNF. So this is what a BCNF. Next, I have just considered this as an example. So I already explained this. Then fourth normal form. Again for fourth normal form, two conditions are there. It should be in a BCNF, and it should not contain more than one multi-value dependency. Okay, more than one multi-value dependency should not be allowed in a fourth normal form. Now can you tell me how many multi-value dependencies are there in this particular table? Can you able to answer? Kushwant, Dikshita, Sanjivani, can you tell how many multi-value dependency? Yes, Kushwant saying 3. Yes, answer is 3. Between course and teacher, between teacher and textbook, and between course and textbook. Okay, one too many. That's why this table is not in a fourth normal form. So to bring this table in a fourth normal form, we'll do the decomposition. we split this table into this through subtable so that it is in a fourth normal form. Next, fifth normal form. Again, two conditions. It should be in a fourth normal form and it should contain joint dependency. So we have already seen what is joint dependency. If I split one large table into number of subtable and after joining this subtable, suppose I am getting original table back, then I can say that there exists joint dependency. Okay. So in this case, I can say that here, suppose I divide this table into three subtable. Now, after joining these three subtables, suppose I am getting this original table back, then I can say that this is in a fifth normal form. So here you can see I am going to join this. So two table I got this I join with this, I got this as a final table, which is this one. So this is in a fifth normal form. So this is all about normalization. Okay, this is all about the normalization. Now next we discuss GATE exam question. Okay, now just read this question carefully. This is GATE question. Okay, you have to read this question. We'll try to solve 1 to 2 questions so that you will understand what type of question will be asked based on functional dependency and normalization, so that it will be helpful to you while solving the question in GATE exam. Okay, so in this case you have to tell me how many candidate key does this relation have. Can you able to answer me? I already explained the procedure how to find candidate key. Now it's your turn. Now tell me answer whether 3, 4, 5, 6. Apply your logic. I will wait for 2 minutes and you just give me an answer. I want answer from your side. How many candidate keys are there for this particular relation? We'll discuss 2 to 3 questions and then we'll stop. Everyone just calculate this. Kushwant, Dikshita, Sanjeevani. Just try to solve this question and give me answer. How many candidate keys are there? Now, how will you solve this question? First of all, you need to identify whether all attributes are reachable here or not. Here you can see G, here you can see BC, C, F, H, A, E, G. What is missing over here? Here D is missing. D is not present on the right hand side. That means D is a essential attribute. Okay. Without D, no candidate key can be formed. Anyone got answer? Kushwant? Did you get answer? Answer is 4. Yes, answer is 4. Now see why. This is how. You just read the explanation. Suppose you found, okay, suppose you find the A closer, okay, you can find B closer, you can find E closer, and you can find F closer. Okay, you can find the closure of all this. Just read the explanation over here. Okay, A closer gives this one, B closer gives this one, E closer gives this one, and F closer gives this one. But what is missing? D. So suppose I join A with D, B with D, E with D, F with D. So we got this 4 as a candidate key. So these are 4 candidate key available for this particular question. Now let's try next question. This one. Okay. In this case, you have to consider functional dependency in given above, and you have to identify relation R is in which normal form. Previous question we discussed about what? In the previous question we discussed about how to find candidate key. Now here we need to identify this particular relation is in which normal form. First, second, third, fourth, fifth. you need to identify. So try to apply your logic. I will wait for 2 minutes and tell me which one is answer. A, B, C, D. Which is the answer? I want answer from your side. I want answer from your side. Kushwant, Dikshita, Sanjeevani, did you get answer? In this case, answer is what? A. It is in a first normal form but not in a second normal form. See, it is the same example as that of previous one. So in this case, there are 4 candidate keys there: AD, BD, ED, FD. And here you can see from A you are getting ABC, from B you are getting CFG. So this is what a partial dependency. Partial dependency means what? Suppose your primary key is formed. So out of these 4, suppose you consider one as a primary key. Suppose your AD is a primary key. So but by using only A, you are finding this value. That means there exists partial dependency. Suppose partial dependency exists in your table, then that table is not in a second normal form. So there is no possibility that this table should be in a third normal form, because we know that if you want table to be in a third normal form, it should be in a second normal form. That's why your answer is A, that it is in a first normal form but not in a second normal form. Why? Because there exists partial dependency over here. So all of you got this? Why this table is in a first normal form but not in a third normal form. Now next question. Here you just try and tell me out of these 4 which one is a key. See, I'm taking variety of question. In first question we discuss about how to find candidate key. In second question we have seen we have to check whether given table in which normal form. And third question we have been given 4 options, and out of these 4 options you need to select what will be the candidate key for this relation. See, while solving numerical based on normalization, you need to consider candidate key. So I will again given you at 2 minutes. Try to give me answer whether EF is a candidate key, whether EFH is a candidate key, whether EFHKL is a candidate key, or E is a candidate key. Now what is the procedure? You need to find closure. Suppose EF closure will give all these attributes, then it can be a candidate key. Suppose combination of EFH is giving you all this attribute, then it can be a candidate key. So you need to find closure, and then you have to decide what is a candidate key for this relation. Try to apply your logic, try to solve it by your own. Try to solve it. C. Okay, Kushwant is saying that answer of this question is C. So answer is wrong, Kushwant. Okay, I will tell you the reason. I will tell you reason why your answer is wrong. So logic is very simple, Kushwant. You are saying EFHKL. Okay, here this one is there. Don't worry, I will give explanation of this. See here. I have got what is EF closure? I will get EFGIJ. So this one is not means we are not getting all the attributes. That's why EF is not a candidate key. Then EFH. Suppose we find closure of EFH, we got all the attributes. That means one of the possibility that it is a candidate key. Next, EFHKL. In this case also we are getting all the attributes. So this is one of the option, and for E we are getting only E. So this is not a candidate key. So first option gets deleted, fourth option gets deleted. But between these two, one option we need to select. Now which one you will select? This one or this one? EFH is a subset of this one. So EFHKL is not a super key. Sorry, it's not a candidate key, because I already told you one condition. Which super key treated as a candidate key? Suppose their subset is not a super key, but here EFH is a subset of this one, and it is also considered as a super key. That's why combination of E, F, H, K, L is not an example of it's not example of candidate key, but E, F, H is an example of candidate key. Did you get this, Kushwant, Sanjana, Nikshita? You got the answer? Why this is why this is will be the answer of this, and then finally we're going to discuss last question, and then we are going to stop. Okay. So sincerely try to solve last question, then we are going to stop. Now I want answer from your side. What are the candidate key for R? You have been given a set of key and you have to identify which is a candidate key for this given relation. Try to solve this question. I will give again 2 minutes, and after that we'll end this particular lecture. Try to find your answer. Try to apply your logic, which we have learned today. How to find candidate key, how to find the closure. Try to apply your logic and try to give me answer of this. A, B, C, D. Out of this, which one is a correct answer? And then we are going to finish this. Anyone got answer? Try to give answer. Then we are going to finish this lecture. Pushwant is saying D. Again, anyone from Dikshita, Sanjeevani? What is the answer of that question? Pushwant, your answer is wrong. D is not answer. Now try for, okay. Dikshita is saying A. Kushwant is saying D, so that answer is also wrong. Now you are left with B and C. Try for B and C. Answer A is wrong, answer D is also wrong. Try to find answer between B and C. Now try to guess between B and C. I have already eliminated the answer A and D. A and D both are incorrect. Okay, Kushwant is saying C. Sanjuni is saying yes. Answer is B. Yes. Answer of this question is B. See here, explanation. Closure of AEH, we got this. Closure of BEH, got this. Closure of TEH, we got this. Sorry. Yes, Kushwant, your answer is correct. Kushwant, the answer of this question is D. AEH, BEH and TEH. Whether it's correct? Did you find the... See, in this case, what is the thing? Which is a mandatory attribute or which is a important attribute? Are we getting H over here? No. That means H is a important attribute. Means one thing is very clear. What are the attribute that we have? That attribute should consist of value H. That's why answer is D. Yes, Kushwant, you're right. Answer is D. So answer for this question is D. Okay. Why? What is the reason? Because H is a mandatory attribute. Without H, no candidate key can be formed for this particular example. And so in this case, H is not there in between in option A and B. So that's why option A and B is not answer. So there is a confusion between C and D. So here these two options are same, but here always have confusion, BCH and TH. See, here I'm last tip I'm going to give you. That how to solve this question in minimum time. First of all, we need to find whether H is reachable. No. So one thing is clear, that whatever the candidate key is there, that should consist of H. That's why option A and B is deleted. Now option C and D. So these two options are same. Only confusion between these two. So I need to find. Suppose I need to find closure of BCH. What we get? Suppose we consider the closure of BCH. Then what we got? BCH. Okay. Then we have to consider whether A is there, no. Whether BC is there, yes. So I will add D over here. Then whether E is there, no. Whether D is there, yes. So I will add A. So whether I got all the attributes A, B, C, D, E is missing over here. Okay. Because here we want E. Suppose there is a E, then I can find. Hence, your answer is D. Yes, Kushwan, your answer is right. Okay? All of you got this? Okay, all of you understand how to solve this kind of questions? Okay. Do you want to solve more questions or we should leave? We should stop here. What do you want? Do you want to try one more question? Dikshita, Kushwan, Sanjeevni, reply so that I can end or will take one more question. What do you want? Just reply fast. Yes, Kushwan saying yes. We need to take one more. Okay, last question. Last question we are going to cover. So last question is based on this. You need to identify what is the highest normal form for this relation. Suppose you are given the schema student and name, course number, roll number, grade, and you have been given this set of dependency. So you need to identify what is the highest normal form for this relation, whether it is in a second normal form, third normal form, BCNF or fourth NF. So this is your this will be our last question. Try to solve it. I will give 2 minutes. Try to answer. Then we are going to end this meeting. Okay, so answer of this question is BCNF or there? No. This particular relation is in a third normal form. Why this relation is in a third normal form? Because here there are two candidate keys are there, AB and CB. AB and CB, these are two candidate key. So here what we have done, we have converted this schema in terms of ABCD. Name is treated as A, course number treated as B, roll number treated as C, and grade is treated as a D. And then here we found that there are two keys are there, candidate key. One is a AB and second one is a CB. Okay, there these are two candidate keys are there, and here we found that there is no transitive dependency is there. That's why this table is in a third normal form. But here we found that the value here, one non-key attribute is finding the value of key attribute. That's why this table is not in a PCNF. That means highest normal form for this table is third normal. So I hope you got how to solve question based on normalization as well as a functional dependency. So at the last I can say you should know how to find candidate key. Suppose you can able to find candidate key, then you can very easily find the on solve question based on normalization. Okay, so thank you very much all of you for joining this meeting. So Roshni ma'am will share one feedback form in Google Classroom. So you need to fill up that feedback form. Yes, Khushwant, Sanjuni and Dikshita, you need to just fill up this feedback form. Okay. Okay, can we end this meeting? Okay, thank you. We are going to end this meeting.